Now we're going to dive into quantitative data. So we're going to look at different displays and, how can we summarize our quantitative data over here. There's many different graphs for quantitative data. We have histograms, dot plots, stem and leaf plots, and so many other graphs. Now, each one of these graphs has, certain advantages and then certain disadvantages. So we use different kinds of graphs for different types of data. So usually histogram is used when we have a lot of data to display. It puts our data into these different classes, so it kind of bunches it into categories, and when we do that, we can see a nice overall shape. So really important when we do this, we want to make sure that if it asks us if we want to bin our data, we generally want to say yes in order to not have a bunch of small little tiny little bars, but we want to make sure we have, for example, over here in our example, we have exam scores with, bin width of 10 over here. So let's look a little bit closer at this graph over here. Some things you may notice is that, we have scores that go from 0 all the way to 110. Usually when we give the range of our data, range is really one number. However, we don't know exactly what the range is, so many times we can write our range from 0 to 10 up to 100 and 110. So usually we write it in interval notation. This just means that our first bar goes from the number 0 up to numbers less than 10. Our second bar goes from 10 to numbers less than 20. Our third bar goes from 20 to less than 30. And then our last bar would go from 100 to less than 110. When we look for unusual values, we look for values that are far away from the majority of our data. So if our data, is over here, mostly values 60 and above or 70 and above, we would look at the tail end to determine whether there is an outlier located or not. Our center of our distribution, we would look kind of at the peaks over here. And, we could again say generally it looks like a lot of people got above 80% over here. Or we could mention that there's a peak between 100 and 110, another peak between 80 and 90. So let's jump into an exercise right below that and, pause the video, answer the question, see if you can come up with the answers, and then look at the answers afterwards. So over here we're looking at data from a meteorologist in Hawaii who's gathered the following average daily wind speeds over 43 days and displayed them in a following histogram. So what percent of speeds was between 30 and 50? And, over here we're looking within these two groups. We want to know what percentage are in them. Now, when we're making these graphs on StatCrunch, we actually have the ability to put numbers on top, so that's always nice. But let's label each one of these. So we have 1 in each bars. There's 2. This goes up to 3. Over here we have 8, 4, 5. This looks like it's 9, another 8. And over here maybe that's another 4. No, that doesn't look right. So these are 6s. All right, so within the group we have 3 plus 6 divided by the total of 43 days. So it looks like we have 9 out of 43 between 30 and 50 miles per hour. All right, so that equals to 0.2093. Again, it's asking for a percentage, so we're just going to multiply that times 100% to give us 20.93%. The next question is asking what percentage of speed was above 60 or below 20. So above 60, over here we have the 4 and the 1, and below 20 we have this one and this one over here. So we have 1 plus 1 plus 4 plus 1, again divided by the 43 total. So that is equal to 7 out of 43, which is equal to 0.1628 or 16.28%. So simply looking at how many are in each bar, looking at the total, oftentimes that's given within the question, and we can find that percentage by dividing the part by the whole.